Question number 5. The diagram shows a block D of mass 100 kgs supported by two sloping struts ED and BD, each attached to an angle of 45 degrees to a fixed point A and B respectively to a horizontal floor. The block is also held in place by a vertical rope CD attached to a fixed point C on a horizontal ceiling. The tension in the rope CD is 500 Newton and the block rests in equilibrium. Find the magnitude of this force in each of the struts AD and BD. For this question, what you have to do, you have to find the magnitude of force in each of the struts AD and BD. If you consider the diagram, you can see clearly over here. This is a block of mass that's 100 kgs is lying over here. The reaction force of this block is moving in the upper direction that have a magnitude of 500 newtons, and AD and BD are placed inclined. So your first step should be resolve this AD and BD into its components. It's horizontal components and vertical component. So whenever I just divide this AD into its two component, then it can be written as TB cos of 45 degrees, because this is AD, means I just mark this AD as a B and BD as a A. So for this DB, it would be TA cos of 45 degrees again, because this is from the point B, so it should be like TA, and it is from the point A. Opposite to that, that would be considered as TB. Draw its vertical components. You can see that vertical component for this one would be like that, that is TB sine of 45 degrees, and similarly for that, that would be TA sine of 45 degrees, right? There is a mass that is acting in downward direction. You know that due to the force of gravity, the weight is acting in downward direction. So that is the mass of a body that is equals to 1100 kgs. You can say as 1000 when you change your kg into gram. By the way, here it's in kg, so it would be 100. Also, there is a forward force that is acting over here is 500 Newton, that will be used in the next step. So I will calculate horizontal component and vertical component for both. So it would be TA cos of 45 degrees will be equals to TB cos of 45 degrees, because if you go back to the figure, you can confirm they both the horizontal components for A and B are equal but opposite in direction, because both have the angle 45. So you can say by using a distributive law of maths, or you can also use the calculator to find the cos of 45 and then do simplification. Otherwise you can do directly. That gives you TA is equals to TB. That is your first assumption that you get from the horizontal component. Now you have to work for vertical component. So vertical component, you can see there is one of a forward force that is acting over this block, that is 500 Newton. So for vertical component, there should be 500 plus TA sine of 45 degrees plus TB sine of 45 degrees, which is equals to 100 kgs, right? It's 100 or 1000. It's 100 kgs, right? So you can put the relevant values over here to find your answer, because it's given to you that TA is equals to TB. So at the place of TA and TB, you can use simply just like T, because that's something just like T. So it will be 500 plus T sine of 45 degrees plus T of sine of 45 degrees, which is equals to 100 kgs. Then you can say 2T sine of 45 degrees, which is equals to, change kgs into gram, then it would be 1000. 1000 minus 500, or you can just only write as it is. So that gives you 1000 minus 500, that gives you 500. You can just consider it as 1000. So after that you can find this t, that will be calculated as 500 over 2 sine of 45 degrees. Hold on your calculator. 500 dividing by 2 times sine of 45 degree is always 1 by square root 2. That is equals to 500 dividing by square root of 2, you can say. And after doing a simplification on your calculator, your value for this t will be 353.6 Newton. That would be the final answer for this question, because this t is equals to ta and tb. So as a whole you can say that is equals to ta, tb for both the components. This answer would be 353.6 Newton. Alright. For B part you can say the horizontal force of magnitude F Newton is applied to the block in a direction parallel to AB. Find the value of F for which the magnitude of this force in the stuck AD is 0. Alright. The thing that you have to use over here is the stuck AD is 0. Means if you go back to the figure, you can see the force that is acting over this component just like that would be 0. When the force is 0, then definitely tension along that AD would also be 0. As a whole you can say TA for that case will be equals to 0. You will calculate the vertical component and horizontal component for that. First of all, I would like to calculate the vertical component. So vertical component, that would be 500 plus TB sine of 45 degrees, which is equals to 1000. Because TA is 0, so vertical component for this TA will also be 0. Just only there is a factor for uh, due to TB, and I'm talking about vertical component, so that's why I'm not going to consider TA cos of theta or just like TA cos of theta. I'm just considering TB sine of something 45 degrees, that is. So after that you can see TB is equals to a TB sine of 45 degrees, which is equals to 1000 minus 500 again, and doing the simplification your TB will be coming as 500 square root 2. I'm not going to explain this step because that's already did in the first part. So after that your TB will be coming as 500 times by square root 2 Newton. That is the value of your TB. Now calculate the horizontal component. Horizontal component, that is also due to TB only because TA is 0. So you have just only TB. TB cos of 45 degrees, which is equals to TB value, that is 500 times by square root 2. Cos of 45 is again 1 by square root 2. This cancel and your answer will be coming as 500 newtons. So that would be your final answer for this for that whole of the question. Hope so you understand.